Am I audible? Hello, everyone.
Yes, sir. Yes, sir.
Okay. Okay, yeah. Thank you. Week 8 is stuff. So yeah. So I think in the last session, Vicky sir has given the overall view of the week 8 content. So today we'll quickly summarize the week 8 and like lecture wise, and then we can go for activity questions, right?
Okay, sir.
Okay. Yeah, so is my screen is visible?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So today I have prepared the slides. Okay, so in the last week we have learned about the limits, right? So yeah, so in the last week, like in the last session, while solving few of the examples, I have used this property. So we'll quickly discuss these properties now. Okay. So this property is given in the slides also. I have taken from the slides only. So like first property is like for limit limit x tends to a f of x that exists at the particular value f, and if for limit for g of x it is given g of x. So then limit x tends to a f plus g of x will give us f plus g. So what does this mean? Say for example, say f of x is say 3x square plus 2, and say g of x is say x plus 4, and limit say x tends to 1. Okay, so now what is limit x tends to 1? F of x will be here, that is 3, right? Sorry, 3 plus 2, 5, and here limit x tends to 1, g of x will be 1 plus 4, that is 5. Okay, so what this first rule says, so when limit like x tends to 1, if I want to calculate the limit of this with the function, like addition of these two functions, it will be f plus g, that is 5 plus 5, that is 10. So what I want to say, like, so suppose we have given the function f of x, that is say x to the power 6, x to the power 5, say 3x square plus say,
connected.
sorry, hello, hello, I'm audible, right?
Right,
Yes,
sir.
sir.
Okay, okay, fine. So let us say this function is there, okay, say sin x. So what I want to say, by if I take the limit of this particular function, limit x tends to 1, I can transfer this limit to individual term. Sorry. So limit x tends to 1 plus 6, limit x tends to 1, x to the power 5. So I can transfer this limit to the individual term, right? Like this. Same in the case of subtraction also. Like if it instead of plus, any doubt in this part? Like someone is speaking. Okay. So like what I want to say, we can transfer this limit if we have addition or subtraction in between the terms, right? So like here also, like say limit x tends to 1, 3x square plus similarly, right? Similarly in the case of subtraction also. Like, and this is for a constant function. Say suppose I have f of x as 4x square plus 4. So I can take 4 as common, x square plus 1. So while taking the limit, say x tends to 1 for this function, what I can do, I can take 4 constant and I can apply this limit x tends to 1, x square plus 1, right? That will be it. Right? So this is the second property. Similarly, like we have discussed subtraction part also. Like, and yeah, so this is a product tool. Like if I want to take the f of g into g of g, say I can transfer the limit to the individual term, individual function, right? And same for this rule. Like say we have take these two functions only, say 3x square plus 2 upon x plus 4. Okay, so now that is limit x tends to 1. So I can transfer this limit to denominator and numerator, right? So it is equivalent to limit x tends to 1, 3x square plus 2 upon limit x tends to 1, x plus 4. Okay. So these are some properties. I think everyone is clear with that, right? From 1 to 5. Any doubt in the property 1 to 5?
No, sir.
No, sir.
Okay.
Yes,
Fine.
sir.
Now there's one important principle, that is sandwich principle. So what does it say? Like say if there is function f of x and limit x tends to a, it is giving the value L. And say suppose for another function g of x, limit x tends to a, like both the limits are same and it's giving me the same value, then h of x is a function such that this condition is satisfied, right? So h of x is between g of x and f of x. So then I can say that limit this h tend to h of x tends to equals to L, right? So so how to apply this sandwich principle? Okay. Say for example, I am taking limit x tends to infinity sine of x upon x. Does anyone can tell me how to solve this limit? Hello?
Sin x plus minus 1 to 1.
Yeah, so the range of this particular sin x function is,
-1 to +1.
yeah, so that is -1 to the +1, right? Now what I want to find out sin x by x. So what I can do, I can divide it by x,
Divide
right?
both side by x.
Dividing by x on all the sides. So that is this one. Now I can take the limit x tends to infinity for all the functions, right? So limit x tends to infinity. So what does this will give? Like minus x limit x tends to infinity sine of x by x limit x tends to infinity 1 by x, right? So what is this limit? What is the value of this limit?
0.
Limit x tends to infinity
0.
1 by x, that is 0, right? And value of this limit also 0,
0.
right? So I can say that by sandwich principle, the limit x tends to infinity sin x by x is 0, right?
Right, sir.
Yeah. So this is one of the important property. Limit x tends to infinity sin x by x equals to 0. And one more thing is there, like limit x tends to 0, sine of x by x equals to 1, right? Okay. Any doubt in this part?
Sir, in the upper case, x
Hmm.
tends to infinity case,
Hmm.
what can we say? What is fx and what is gx?
What is
Between-
f of?
Sir, yes, sir.
No, this is the value of this particular limit, right? So here you can see, right?
Sir, I am asking, what can we say? Among which functions is this limit sandwiched? Upper limit.
The value of this upper limit from -1 by x to this 1 by x, right?
Yes, sir.
Yeah. Okay, so we'll see one application of this example only. This screen is visible, right? Blank screen.
Yes, sir.
Okay, say suppose I have sin x, 7 sin x, right? Plus 3x plus 17. Say limit x tends to infinity. Now, how to solve this question? By sandwich principle. Does anyone?
Divide both numerator and denominator by x.
Okay, so what I will get here, like 1 plus 7 by
7x by x.
sin x by x, here 3 plus 17 by x, right? Then I can apply the limit. Now this will give me like 1 plus limit 7 sin x by x, like x tends to infinity, upon 3 plus limit x tends to infinity 17 by x, right? So this is equals to 0.
0.
Yeah, and this limit is we have just discussed now, right? it is equals to, like,
Zero.
you can take constant, say one constant outside, and sin x into x, limit x tends to infinity, that is 0, right? Yeah, so 7 into 0, 0. So we'll get the answer 1 by 3, right? So the value of this particular limit is 1 by 3. But I want to apply sandwich principle here for this whole function. How I can apply? Okay, this is fine.
Same as previous approach, we have to take sign
Yeah,
range -1 to +1
sin x, that is from -1
to +1.
to +1. Now,
Now we
Multiply
have
by
to multiply by 7, I guess.
yeah, multiply by 7, 7
And add x.
sin x, yeah, plus 7. Adding x, x minus 7, x plus 7 sin x, x plus 7. Now divided by this whole function, right?
Right, sir.
Yes,
Yeah,
sir.
so x minus 7, 3x plus 17, x plus 7 sin of x, 3x plus 17, and x plus 7, 3x plus 17. Now we'll apply a limit to all the three functions, right?
Yes, sir.
Yeah, so what will the value of this limit?
One by three.
How to evaluate? Limit x tends to infinity, x minus 7 upon 3x plus 17. When-
We can put infinity instead of x, in place of x.
Sorry, in place of?
X.
No, whenever the limit x tends to infinity, what we have to do?
Sir, we
Take a
can
common
divide
x,
it
sir.
by x, sir. Both
Yeah.
numerator and denominator. We can divide it by x.
Yeah, we can divide it by x, right? X tends to
Yeah.
infinity. So 1 by
1 minus 7 by x.
x
Upon
upon
3
3
plus 17 by x.
by x, right? So I
It will
can
give
put
1 by
now,
Now
3.
it will 0.
we got
Yeah.
1 by
No,
3.
it will come to 1 by 3, sir.
Yeah, and same for this function also, right?
Then we will divide it by x.
It will be
Numerator
1 by
then it
3.
will get 1 by 3.
If we divide it by x, so we'll get 1 plus 7 by 3 and 3 plus 17 by x, right?
Right, sir.
If we apply the limit, we'll get 1 by 3. So
So
value of this
so the limit of
is,
middle one will be also 1 by 3.
yeah, so by sandwich principle, we can say the value of this function also is 1 by 3.
1 by 3.
Yeah. So please note down that whenever there is any trigonometric function, say sin x or cos x, because for this we know the range. This for cos x also same thing is there, right? Instead of sin x, if there is cos x, it varies from -1 to 1 only, right?
Right, sir. So,
So
for
in most of
trigonometric
the-
functions, we can use sandwich
Yeah.
principle.
So whenever there is sin x and cos x, so just think about the sandwich principle, okay? Otherwise, you can follow our rule, like take x common. That is also doable. But whenever you have asked to solve the specific question by this using principle only, so there should be, like in most of the question, there will be trigonometric function. Okay. Yeah. So I think if you're given a complex any function, you can do like this. Okay. So you can multiply by 7, you can add the function, you can subtract the, you can divide the function, right?
Sir,
Yes,
we
sir.
apply sandwich principle only on bounded function then.
Yeah, only bounded function. Yeah. Yeah. Okay, so any doubt in this part?
Well, in this part, which you have calculated limits without using sandwich principle, the last second statement on left.
This one.
Yeah. This one.
Yeah. So here, like whenever limit x tends to
I got that, sir. Last statement. Just
This
last.
one.
Yes. This one. Yeah.
Yeah. So I transfer this limit infinity to this particular function, right? Limit 7 into sin x by x. So I can take 7 constant outside. Limit x tends to infinity sin x by x. So in the previous
Yeah.
slide, we already discussed that limit x tends to infinity sin x by sin x equals to 0, right? So I have
Okay,
directly
so
used
we
this
need to
property.
know this, that when limits tends to infinity, sin x upon x is 0.
Yeah, this you can say one of the
Because
standard rule. Yeah.
the standard we have, what we have learned is limit x tends to 0, sin x by x is 1. Okay, we haven't learned
Whenever the
about
limit x
infinity.
tends to infinity, it will be 0. When it tends to 0, it will be 1.
Okay, sir.
Here you
Thank
can
you.
see we have
I
discussed.
got it. I got it. Thank you.
Hmm. Okay, so now we'll
Sir, I
discuss.
have a doubt.
Yes.
Like all the examples you showed for sandwich principle, the two limits which sandwich between is like 1/3, right?
Hmm.
It's the same. Other instances where it will be a different,
Sorry, where it will be?
like it's like actually the value is, I mean, different. Like it's both like 1/3 and 1/3, right?
So if the value of this function is different, say 2/3, you're talking about.
Yeah.
So in that case, we cannot apply the sandwich principle. Right? By definition, you can see the limit of this function is L. The limit of this function is also L. So then I can say that limit of h of x is L. Right?
Okay.
Yeah. So limit on the both the sides should be same. Then we can say that the limit of the middle term will be L.
Okay.
Lots of noises.
Got it, sir. Thank you.
Okay. Okay, so now about the continuity of a function. Okay, so the function f is said to be continuous if it is continuous at all the points in its domain. So for all the points A for which f of a is defined. Yeah, please. Hello, Shilpa, you want to ask something?
Yes, yes.
Uh,
So I was a little concerned that these concepts they've been covered in the last session, and I think it would save us some time if we covered the
Portion.
L'Hopital's rule, yeah, and some advanced questions, and plus the I think the chain rule.
Derivative. Yeah, okay.
Yeah,
That yes, we'll discuss. I'm just quickly going through the content. Just 1 minute.
yeah. I mean, I was not sure what the agenda is, but just wanted to.
Yes, we'll go through module wise, lecture wise. Yeah, I will cover the part also. Derivative part. Don't worry. Okay, so suppose there is so about the continuity of a function, like this is the definition. Like if you remember, like in the last session that I took, I discussed one example, like x square by x square minus 9, x minus 3. Okay, so we have to find out limit x tends to 3. Okay, so this function is not defined at x equals to 3, right? It's not defined at x equals to 3. But still we have calculated the limit. Okay, so what is the limit of this function?
Yes.
X plus 3, x minus 3 upon x minus 3, right? So I can cancel it out. So limit x tends to 3 will be 6. Okay, so what I said, what I meant to say that, okay, so the limit of this particular f of x is x, that is equals to 6. But what is the value of f of 3 here? If I put 3 here, right, it will be 0/0. It will be indeterminate form. So I can say the limit of any particular function exists, but it is not continuous. Okay. So by definition, this condition should satisfy, right? So our limit x tends to 3, f of x should be equals to f of a, right? So for a continuous function, there are 3 rules. So first one is limit should exist at that particular point.
It means at a point 3 it is not defined. If
Yeah,
we
it is
put
not
value
defined.
of 3, it is undefined. Yeah.
Yeah.
So
right,
it is
x equals
discontinuous
to
at
3.
at the value 3.
X equal to 3. Yeah. So it's just discontinuous at x equal to 3.
Yes,
Right?
sir.
So limit should exist, and the second condition is like this. So limit x tends to a, f of x equals to f of a. Right. Limit should exist means what? The left hand side limit must be equals to right hand limit, right? It should exist. Both the limit should exist and should be equal. So here you can see this example. Limit exists, but it is not continuous function. Okay. So you can remember this equation. Right? Okay. So it's a simple definition of a
Sir,
yes.
sir, if you can explain the activity 8.1 first question.
Yeah, okay. I will discuss the question first. I have taken few questions from activity only. I will discuss those questions. Okay. Yeah. Okay. So this is this question from activity only. Okay. Tell me how to solve this particular question. We have to check whether this f of x is continuous or not.
First, we calculate left-hand limit and right-hand limit and see if they are
Continuous at any
equal.
point.
Sorry. We have to check
Continuous
whether this
at-
function f of x is continuous or not. Okay. So first we have to check limit should exist, right? And second one is that limit f of x should be equal to this limit, right? So now this function is continuous when x is greater than 1. This function is continuous when x is less than 1. That is 1 by 6. That is constant, right? So we have to check at x equals to 1 when x tends to 1, right? So how to? So what is the left hand limit for this? Left hand limit for this f of x? What's
1 by
the-
6.
1
1 by
plus
6.
Yeah, so limit x tends to 1,
This
x upon
1 upon 6.
plus 1. Okay, sorry, left hand limit, right? Yeah. We are
1 by
considering-
6, sir. Left hand limit is 1 by 6. Yeah.
Yeah,
1 minus limit will be extends to 1
This-
minus.
left hand
6.
limit will be 1 by 6, right? Now what is the right hand limit?
The value of f of
1
x,
plus.
x upon x plus 1 into x plus 2. So it is 1.
I can simply put 1 here, right?
Yeah.
So 2 into 3, that is 1 by 6.
1 by 6.
So my left hand limit and right hand limit exist. Okay. So I can say limit at x equal x tends to 1 exists. So now our second condition is f of x limit x tends to a, f of x should be equal to f of a. So now what is f of 1 here? This is a function, right?
1
And
by
x equal
6.
to 1. Yeah. I can put here directly 1 as 2 into 3, that is 6. Okay.
1 by 6.
So I can say this function is continuous, right?
Yes,
Yes,
sir.
sir.
Yeah. So in the next question, we have to find out the value of a and b such that this function is continuous. Find a and b such that this function is continuous. How to do that? We have to follow simple those 3 steps. But the limit exists at x equals to 1.
Sir, in the question, it is also already given it is continuous.
Yeah. So find a and b if f is continuous, right?
So we can equate left hand limit and right hand limit
Yeah.
along with values.
Yeah. So what we will get? Limit, it is left hand limit. Limit x tends to 1. Bx,
1 minus, yes,
B.
Yeah. So it will be b.
b.
Now limit x tends to 1 plus.
1 plus
What will be the value?
A.
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 Yes, sir.
Right. So this limit should exist. Like so, left hand, right, left hand
A equals to
right
B.
limit. Yeah.
is
A is
equals
equal to
to A.
B.
So that will be a equals to b.
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 Right. So in the question, I think there are a few options also. Let me check. Okay. Can you see my this this
Yes,
file is
sir, yes,
visible?
sir.
Yeah, yeah. So f is always continuous.
Yes.
We can say that
How?
f is always continuous. Okay.
With respect to the value of a, f is continuous.
Sir, it depends on A and B, no?
A and B,
Depends on
right?
A
Yeah.
and
So
A.
this is not correct.
Yeah.
F is continuous if and only if a equals to b equals to 0. That is not also true, right?
Yes, sir.
No,
Yeah.
not
false.
true.
It should be a equals to b only. That is the sufficient condition. Yeah. So this is
This is
true. And f is continuous if a equals to b equals to 0. This is also true, right? Okay.
house. The third one.
No, no. A equal to b means it can be any value, equal to 0 or it can be
Any
1, 2, 3.
value.
No.
Yes, okay.
In the second option, it is saying if and only if, right?
No.
Equals to 0. That this is not correct. Yeah.
Okay.
So now here, okay. So this is a function given. This is the seventh question. We have to find out the a plus b, value of a plus b. Okay, so f is continuous, it is given. So how to do that?
Same approach, sir. Continuous is given, we can equate.
Yeah. So what will be the left hand limit? Limit x tends to 0.
Sin ax upon x.
0 minus, and then
Huh?
it is b
Sine of ax by
sin
x.
ax by ax. Yeah.
So what will be
It
the
will
value
be
of
a.
this? How to evaluate this limit?
Multiply and divide by a.
A, sir. This will be A.
So we can multiply and divide it by a, right?
A value is A,
Yes,
sir.
sir.
Yeah, so I
This
can
is
take
equal to A.
x tends to 0 minus sine of
Ax
ax
by Ax.
upon a. So this
This
is
is
equals to
1.
1, right?
This is
Yeah.
one.
Then A into 1
This
is equal
limit
to
equals
A.
to 1, right? So this limit is equals to 1.
Yes.
So I can say it is a, right? So
A.
left hand
A.
limit is a. Now what is right hand side limit?
Right, and X by
0
tan
positive,
inverse 2x.
and then
Okay, tell me
X
how to
upon
do this.
tan inverse 2x.
Yeah, how to do
We
this?
have to
Divide
L'Hopital
by
rule on
2
both
and multiply
sides.
by 2x.
Okay, one
L'Hopital
by
rule.
one. Okay, tell me first.
Dividing by 4x square, sir. 4x
Dividing
square.
by 4x square.
Yeah, numerator and denominator.
So what I will get? 4x square. Why 4x square? Why 4x square?
Yeah.
But why?
And
Why? Yeah, why we have
because
divided?
we have to put it in the formula to apply the limit formula in the inverse function. 1 plus 4x square it should be, I think.
Tan inverse x upon x square.
We have to convert it into a standard form, sir.
We have to, I think
Tan
we have to do
inverse
L'Hopital rule so that it is
tan inverse
Okay.
x by x is 1. So we have to
Okay.
convert it anyhow.
See, there are two approaches. First thing, like, so first way is L hospital rule, right? So for that, what we
yes,
do?
sir.
If we
L'Hopital
put
rule.
0
The
here,
above one will
0
be
by 0.
1.
It is indeterminate form, right?
Yes, sir. 0
Yes,
by
sir.
0.
So we have to differentiate numerator and denominator. So what will be the
Yes.
differentiation of
Upper
numerator?
one will be 1
Okay.
and the lower one will be 4 by 1 plus x square. 1 plus 4x square.
What is the differentiation of tan inverse x here?
Root over 1 plus x square.
1 upon 1 plus x square, right?
X square. So no root over, sorry, 1 plus x square, right?
Yeah. So it
So
is
here
2x.
2x.
So we have to
So it
divide
will
this
be
2x
4.
also by chain rule.
Yeah.
Yeah. So that is 2. And here it will be 2x, right?
2x. Yes.
So 1 plus 4x square into 2. Right?
Yes.
Yeah. So wait. This is not correct.
Something.
Yeah. So
I did that
here,
math before.
1 upon 1 plus 4x square into 2, right? We are taking the derivative of this, right?
Yes, yes.
Yeah. So it will be limit x tends to 0, 1 plus 4x square in the numerator divided by 2. Now you put x equals to 0, what you will get? 1 by 2, right?
Yes.
Okay, this is if we know the L hospital root and if we know the derivative of this tan inverse x. So what if I don't know the derivative of this function and I don't know the L hospital rule also? How should I solve this question? Any different approach? Anyone?
No, sir, don't.
Sir, I have a doubt.
Yes.
Sir, the formula which is u upon v dy dx u upon v into dy dx u minus u into dy dx.
Numerator and denominator by 2x.
That is quotient rule that we are not applying. For limit or for applying this L hospital rule, we have to differentiate numerator and denominator individually, right? So ddx of numerator and ddx of denominator.
Okay.
Yeah. So this x of differentiation of one is x is 1 and for tan inverse 2x is 1 upon 4x square into 2, right? So is there a different approach? Like if I don't know the derivative of this tan inverse and I don't know the L hospital rule. Yeah.
So if we divide a numerator and denominator by 2x, so
2x, okay.
Yeah, so the denominator will become 1 and then xx will cut from the numerator and then half will be direct answer.
So this is equals to 1. How? How? You are saying this limit is equals to 1, right? Is it true? For tan x upon x, limit x tends to 0. We can say this is equals to 1. Right?
Yes, sir.
It is inverse of tan, right? Not tan x. You cannot do like this, right? So how to do that? How to find out the this particular thing? Yes, anyone? Any different approach?
We have to convert into standard form, but
Yeah.
I don't know
Sir,
how to
I
approach
have
that.
one.
Tan inverse equals to theta,
I
then
wanted
like
to
this.
say that.
Yes, yes. You have if someone is saying, yes.
Yes, sir. Sir, can we write like tan inverse in terms of some cot 2x kind of things?
Yeah.
If
So we
any
can say, okay.
conversion.
For example, t
Yeah.
sorry, not t, m equals to tan inverse of x, right? So m equals to tan inverse of 2x, right? So instead of tan inverse of 2x, I'm writing m. Right? So
2x
what
equal
is
to tan m.
2x equals to tan of
Tan
m? So what is x equals to?
Half of tan m.
Yeah, tan of m by 2. Now put this m equals to tan inverse of 2x and x equals to this in equation, right? So what I will get? Limit. Okay, one more thing. So what is the limit? So when limit x tends to 0, my m will tends to what? If I put x equals to 0, it will be 0, right? So m will also tends to 0. So we have to change the limit also, right? For this particular variable. So when limit m tends to 0, what is x? Tan m by 2. And what is tan inverse of 2x? That is m, right? So I can
Yes,
write it
m.
as 1 by
Okay,
2
this is also
outside.
half. Yes.
Yeah, tan m upon m. So 1 by 2 limit m tends to 0, tan m by m, this is 1, right? This is 1. So I will get 1 by 2,
Yes.
right? Any doubt in this part? Like I have just substituted m equals to tan inverse of 2x, and instead of x, I have put this, right? Then I have solved this question. Yeah.
Sir, we are substituting just because we don't know the value of tan inverse x upon x, right? We have to convert it in form of tan x upon x.
Yeah, standard function. Like
A standard function. Okay.
this is one of the way to approach the question. Okay. Yeah. So okay, what we have to find out value of a and b. So what is a and b? Okay. So from the first condition, limit a. Okay. So if it's continuous means left hand limit should be equals to right hand limit, right?
Yes.
So my a equals to 1 by 2, right? My left hand limit is a, and my right hand limit is 1 by 2, right? Yeah, and also another condition is limit x tends to 0.
0 is equal to
F
b.
of x equals to f of 0, right? So f of 0 is b, and my limit x tends to 0 is a and 1 by 2. So I can consider this a. So a equal to b, that is 1 by 2. So a plus b will
Plus
be
b
1.
half plus half is equal to 1.
Yeah, so a plus b will be 1, right? So 1 is the answer. Any doubt in this part?
No, sir. Clear.
Okay. Okay, any doubt in the activity question 8.1?
Sir, question number 1.
This one.
Yes, sir.
Yeah, so if limit x tends to f of x equals to n, which of the following statement is true? F is defined at a. Can you say that if limit exists, then x defined at a? No, because in the beginning only we have discussed this example, right? X square minus 10, x minus 3. It is not defined at x equals to 3. But still we have given the value of limit is 6, right?
Yes.
Yeah, so this is not true. Okay. So limit x from left hand at a minus will be L. Okay, if this limit exists means left hand limit should be equals to right hand limit. So this is correct. This option is also correct. F of a is equals to L. No, we are. It is not a continuous function. We are not given the f of x is continuous function. So this is also not correct. So f is continuous at a. No, we cannot say directly, right? If f is continuous or a. Because we are
Sir,
simply-
third option, I think to be correct. F of a is equal to L because तभी तो limits are x tends to a fx is equal to L होगा.
No, for we have given only this thing, right? Limit x tends to a, f of x equals to L. That's it. We have not given that f of x is continuous or anything. Right. From this, I can say, okay, my left hand limit should be equals to right hand limit. This is the only thing I can infer from this particular thing. How you can say that f of a equals to L? Take the example of this function only. This is f of x, right? And this is a equals to 3. My limit is equals to 6, but f of a equals to L. No, na. F of a equals does not exist here, right? Because it's not defined at this particular point.
Okay.
Yeah. So this is also not correct.
Sir,
Okay.
I have a doubt
Sir.
in activity 8.3.
Okay.
Sir,
Next
question
one,
number
I
2
will-
is in same activity, sir. Question
Yeah,
number
same
2 and
activity
3.
you can ask. I will go for
Yeah, yes, sir.
on the-
2.
yeah. Yes. What is your doubt here?
Sir, doubt basically f of x minus 10. If minus 2 x to
Left
2
hand limit
minus
of
x
this one.
10. Yes, sir.
Okay. So 2 minus 10, we are going from left hand side, right?
Left hand side.
Yeah, towards 2. So
Yes, sir.
if we are going from left hand side towards 2, what is the value of this function, right? 10, right?
Yes.
Yeah, so this is option is correct. If you go from the right hand side, what is the value of this function? 2. Second option is also correct.
And second option is correct. I have put it this 2 plus. Okay. Then, sir, for sir, limit x tends to 4 minus fx equal to 4. How it is incorrect?
Yeah, so we are going from left hand side, right?
And plus 4 also.
Yeah, so we are going from left hand side for 4 minus. So what is the
Yes.
function? And this function, right? I'm going from this side, right? So it will be 10. It will tends
10.
to 10. Yeah.
10.
If I'm going from this right hand side, what will the function? This function, right? It will
4.
tends to 4. Here you can see, right?
Okay. Basically, I am considering this point only one point.
We're going from this 2 minus on the left hand side and 2 plus on the right hand side. We're approaching this particular point, right? We are not
Yes, yes.
at that point. We're approaching that point.
Okay, sir. Okay.
So f is continuous at x equals to 6. Right? X equals to this is continuous. You can see from the graph only, right? This is also
Yes,
correct.
sir. Correct. Yes. And
Okay.
sir, question number 4, sir. How to do it?
We have discussed this question, right?
Okay.
Just now
Okay, sir.
only.
I have joined late.
Okay.
Another
This question.
Question 5.
question
5
5.
only we have discussed. No?
Okay.
Okay. This one.
Yes, sir.
There exists a continuous function f such that f of 3 is okay. Can you tell me any function that such that this is domain, this is codomain, so such that the value of this particular function at x equal to 3 will be x, sorry, pi. Is there any function like this? So I can consider this as f of x equals to pi. This is a constant function. Okay, sorry. Yeah. So I can consider this function, right? F of x equals to pi. This is constant function, right?
Right, sir.
Yeah. So this function is continuous everywhere in this domain also, right? I can also consider this as pi of 3 into x. So if I put x equals to 3, I will get pi, right?
Okay.
Yeah. So it is
So
from
this
this
option is
domain.
correct.
Yeah, this
F
option is
of
correct.
x equal to pi.
There exists a continuous function. It can be any function, right?
Actually,
Yes, it
how,
is.
sir, domain part is 1 and 5 to 1 to 7. So how to put this f of 1 equal to f of 5 equal to like that?
Yeah, if you put x equals to 1, I will get the value from 1 to 7, right?
1 to, yes.
Yeah, that is. So this is a constant function, right? It is continuous
Yes.
everywhere in the domain also. So this is
Okay.
one of the function. So this option is true, right? There exists a continuous function. We have to think about any function such that it is in domain and it is giving me this particular value.
Okay, sir.
Okay. Yeah, same for this option 2 also. Now for option 3, there exists a non-constant continuous function. Okay, can you tell me any non-constant continuous function from R to R which is bounded? Any function is there? It's non-constant. Constant function is like this: f of x equals to 3.
Sin x.
Sin x.
Yeah, sin x. Yes. If you draw the graph of sin x like this, it will range from 1 to 1, right? 1 to minus 1. And it is bounded, right? And it is non-constant also. And it is range from R to R. So this option is correct. Right, this is my constant function, right? If I consider this constant function, this is continuous everywhere in the R.
That means the constant function is continuous everywhere, R to R.
Yeah, it is everywhere, R to R.
Sir,
Any
how
constant
sin x is?
function,
Sorry, one doubt only. Yes.
any constant function is continuous from R to R.
See, continuous means what? Say value of pi is 3.14, right? So I can draw a simple line at 0. This is 3.4, y equals to 3.4, right? It is continuous everywhere in the range. It's a simple line, straight line. Yes.
Sir, sin x, how non-constant? Sin.
No, constant function means there is no variable. That is
okay.
F of x equals to pi or any constant number, right? In sin x is a variable, right?
Yes, it's very
so it is
non-constant.
Non-constant.
Okay.
Sir, but range of sin x is minus 1 to 1. So how can we say it's R to R?
Like it is a codomain, right? It is a codomain. So range will be the subset of this codomain, right? So minus 1 to 1, right?
Okay, sir.
Yeah.
Sir, 4 option, can you plot the graph for this?
Which?
For option number 4.
There exists an unbound continuous function from 2 to 3 to R. Okay. So any function it's unbounded. Anyone?
Unbounded functions. 10x, yeah.
Tan theta.
Tan theta.
Tan x. Okay.
Tan x.
Yeah.
Tan x. Yeah. So it will vary from minus infinity to infinity, right? R.
Yes.
Okay, yeah. This is also unbounded. Yeah. Tan x is unbounded.
Yeah.
Right.
Unbounded, sir.
Yeah. Okay. So this is also correct. Okay.
Sir.
Yes.
So in that option 2, sir. So in the question which we discussed, so f of 1 and f of 10 represent the same function.
The same function, yeah.
So in option 2. So sir, I was asking that what should be the means like approximate function if we try to make it.
Okay, so we have to find out such that like f of 1 will be 3 and f of 10 will be 5.
So means like I didn't all the option I'm clear with, but this option how it is continuous. So like
so we have to think about any particular function which is continuous and which will give me this value, right, from this domain. So any function, anyone? Yes. Anyone? What will be the value if I put 3?
so means like without the example, how you concluded that it is continuous?
Like in first option we can consider, right?
Yes.
So there exists some, yeah.
So we take any option or functions are in here.
So like to prove
A
this,
continuous function only, a constant function only we can take, but f of 10 is not, will be not equal to 5, right? If you consider f of x equals to 3, then only this condition will satisfy, right?
Yes,
not
sir.
this one. Yeah, so it is not a constant function. It must be a variable function only, but what is the function? We have to think about that function.
Yes.
Yeah. So I have given function is 3, 5. So my when y equals to 1, x equals to 3. and then y equals to 10, x equals to 5, right? If I put like this, no, it will not be correct, right? Okay, so we have to think about this function.
Yes, sir.
Sir,
As
it
of
can be
now,
any complicated function.
it can be any complicated function, yeah, right? But there exist some function, right? Okay, I will.
So means like if only if even one example is true, then we will mark it correct.
Yes,
Okay.
correct, yeah, there exist. Okay, I will think about it and let you
Yes,
know.
sir.
Okay?
Thank you, sir.
So the last question, please.
From same activity,
This particular activity, so 8.18.
8.1 last question. No?
So like just how to go about solving this one?
This function, question number 8.
Yes, sir.
Okay, function is done. Yep. So we have to find out the left hand limit and right hand limit, right? So what will be the left hand limit? Limit x tends to 0, 1 upon to the power 1 by x plus 1. So this is not a standard function, right? We can apply. Yes, anyone? You have to go by definition only here. What is the definition of limit? Like, say this is my any function, right? Now I want to find out okay. So now I want to find out the limit at this particular point A, right? So when I'm going from a left hand side, I don't know whether this limit at point exists or not, right? It can be break here also, right?
Sir, we can easily see that here left hand limit and right hand limit is same because x is not equal to 0.
No,
Here,
at
if
f of 0, it is 0, right?
yeah, but if x is not 0, then it is 1 upon e to the power 1 upon
Yeah.
x plus 1. So we can see that left hand limit and right hand limit is equal at the value 0.
No. We have to find out that. We have to verify that. Directly we cannot say, right?
Sir, it is x is not equal to 0.
Hmm.
So we can see that if we put the value, take the left hand limit and right hand limit, both will give the same value. Both will give the same value because x is not equal to 0.
See,
Yeah, he is right.
Yeah, easily we can see whatever the value of this function, no problem. But here x is not equal to 0. So obviously left hand limit and right hand limit is same.
Okay, this is my y.
But the option says LHL and RHL are not equal, right?
So option 1 is wrong. Option 1 is wrong.
No. See. If I put x equals to 0 here, I will get e to the power infinity, right?
Yeah.
Yeah. So if I approach this thing, okay, for infinity is infinity 1 upon infinity 0 only, right? No. For this function, we are getting the that x equals to 0. But f of 0 equals to 0. But limit x tends to 0 or what we have to change, right? For this particular function, when we tends towards the x, so sorry 0, are we getting the like both the left hand limit, right hand limit is same or not? That we have to check, right?
Sir, both are coming 0, right hand limit and left hand limit.
How?
Sir, 1 upon e, when s tends to 0, if it is minus h or plus h, it becomes e to the power left hand limit is 1, sorry.
Okay, say suppose this is any function and this is point A. So we have to check whether this limit exists at point A or not. So what we can do, we can consider 1 point here and 1 point here, right? So by difference h. So if I go from the okay, wait. Let me check. Okay, so this is point A. Now I
Sir,
have.
Sir,
yes,
we can to find the limit. We can also put one upon x is equal to y. 1 upon x is equal to y, and if
okay. 1 upon x equals to y.
Y and put the value 1
Then
upon
no, no, no.
e to the
See,
y
see.
plus.
No, no. So 1 upon x equals to y. So we have to find out when x tends to 0, when y will tends to
Y tend to
infinity.
infinity. Y tend to infinity.
So when y tend to infinity,
Infinity. Yes.
1
1 upon e
y
to the power
plus 1.
e to the power e to the
E to
y.
the power y plus 1.
Yeah,
That is
and
infinity.
we can also divide the numerator and denominator by y.
So we can also multiply both up and down with e to the power x, then
Okay.
e to the power
Wait.
x by e to the power
Let
x
us go
plus
by the
1.
definition first. We will see. Okay. Because it's a complex function, it is not any polynomial function. Okay. So what I want to say, like when you're going from the left hand side, so we are approaching this value of a. We are not finding the value of function at particular this point. We are just approaching this towards this particular point. Okay. So I can consider this this point at a distance h, right? So what is my left hand limit here? So when I limit x tends to 0, so let us say 0. So I have to find out limit a minus h, right? Because I am subtracting this very small distance from this particular a. Okay, so if I put instead of x, that is a minus h, what will the function? So limit x tends to 0, 1 upon e to the power a minus h plus 1, right? So now a is 0, right?
So, but e raised to power 1 upon minus h.
Wait. So it will be e to the power 1 upon minus h plus 1, right? Limit x tends to 0. Now, if I put 0 here, I will get e to the power minus infinity, right? And that is equals to 0. So now I am getting 1, 0 plus 1. Right?
1 e की power 0 होगा.
Sorry. Okay, wait. E to the power minus 1 by h, right? So if I put h equals to 0, it will 1 by 0 is infinity, right? So it will be e to the power minus infinity, right? So e to the power minus infinity will be 0.
Yes.
So if I put 1, 0 plus, it will be equals to 1. See, right? It is not equals to 0. I am not finding out the value of this particular function at x equals to 0. It is 0. It's already given to us, right? When we are approaching this function towards the 0, what will be function will tends to, right? So that is the what limit is. So yeah. So if I go from the right hand side, I have to consider a plus h, right? So if I consider
1 by h.
Yeah. So limit h tends to 0, 1 upon e to the power 1 upon h plus 1. So now here 1 upon
Plus infinity.
Infinity will be 0. Yeah. So you can see my left hand limit and right hand limit is not equal. Here I am getting 1 and here I am getting 0.
Sir, here we can also use epsilon formula and delta formulas. We can get.
The delta formula means you are considering this small
Yes,
value only.
like from the right side and the left side, we can consider 2 points. So this is same as that.
That thing only. Yeah. Instead of delta, I have used h here. That's it. Yeah. If I'm going from left hand side, I'm considering a minus h, and if I'm going from right hand side, I will consider a plus.
Yes, sir. For every delta, we get the epsilon and in that particular.
Right. So this function is not defined at x equals to 0. This particular thing, right? But I am getting x equal to 0 here. So what will my graph look like for this function? Like everyone understood, right? My left hand limit is not equal to right hand limit. So my left hand limit is 1 and my right hand limit is 0, right? So if I draw the graph,
Sir, one question. E to the power minus infinity is equal to 0, and e to the power infinity is equal to infinity, right?
Yeah. So I can write this at 1 upon e to the power infinity, right?
Yes.
Yeah. So 1 upon e to the power infinity will be infinity. It is equals to 0.
Okay, and e to the power infinity.
E to the power infinity is infinity only, no? Okay. Do one thing. Try to plot the graph of this function on this note. Okay. See whether our assumption is like our calculation is correct or not. Okay. I think limit will not exist. Yeah. If I go by the definition, limit will not exist. Okay, but we should mention here, like I think some condition we should mention, right? Okay. Okay, anyone just try this function on this note, okay? You can check it out.
So seeing how this is like a complicated function, like will we be getting such type of questions in quiz 2?
Yeah, we can expect such question, but yeah.
Like takes some comprehending to understand the question.
So if there's some complex function like this, always go by the definition. Like just consider 2 points, just left hand side point, a particular point, and consider this a minus h. And when we are checking for the right hand limit, it will be a plus h. Okay, and then h tends to 0. Because when we h tends to 0, this function will become a only, right? In both the cases.
Yes, sir.
Yeah. So this is by definition only we are checking.
So we just replace a with h, and then
Just replace x. Just replace x by a minus h when we are calculating left hand side limit, and well, we are calculating right hand side limit, just a plus h. Okay, replace x by a plus h. Okay. I will check with the team whether this any condition is required or not, right? Yeah. Okay, any doubt? I think this is lecture 8.2 now.
Yes, sir.
Yeah. So now about differentiability. By definition, like let f be a function defined on an open interval around a, then f is differentiable at a if this particular limit exists. Okay. Now the function f of x derivative function. The value of this particular limit will be the derivative of this particular function. Okay. So now let us take one example. Say f of x equals to x square. Right. Now just find out the limit this. Now limit h tends to 0. I have to replace x by x plus h here, right? In the f of x. So what will the value? X plus h by whole square, right? Minus f of x. What is f of x? That is
minus x square.
That is
by 8.
Yeah, 0. Now just expand it. That is x square plus 2xh plus h square minus x square upon h, right?
Yes,
so
sir.
this is cancelled. You can take h common, that is 2x plus h upon h, that is limit h tends to 0. I can cancel h, right? And I can put x equals to 0. So h equals to 0. So I will get 2x, right? So the derivative of f of x is 2, x square is 2x, right?
Right, sir.
Yeah. So if this limit exists, means that there is this particular function is differentiable at point A. Okay, and that value will be equal to that limit value. Okay, so it is denoted by f dash also. You can call it a f prime also, and this is also df by dx. This is also notation for derivative. Okay, so this is a simple thing. In domain consists of those points at which function f of x is differentiable. This is simple, basic thing. Just remember this formula. Okay, like we are finding out the whether differentiable or not. We have to check this condition only. Okay, so solve this limit only. Okay, so we'll discuss one example here. This from activity only, last question. We have to find out the value of this. Okay. So anyone try out this question? We have given two conditions.
Yeah, this is a problem, sir. I have issue in this question.
Okay. So, okay, what is, we have given f is continuous, right?
Right, sir.
Left hand limit equals to right hand limit.
Right hand limit is equal
and
to
f of a equals to limit x tends
limit
to a f of x, right? So these
Right,
two
sir.
conditions should satisfy.
Yeah.
Okay, now let us apply this condition. What is left hand limit here?
K plus L.
This one, right?
K plus L, sir.
L minus will be kx plus L. So it will be K plus L, right?
Yes, sir.
What is the right hand limit?
L plus K plus M.
So it will be Lx square plus Kx plus M. And I put x equals to 1, it will be L plus K plus M. Now, if my function is continuous, then I can say this limit is equal. So what if this equals to this left hand limit, it is K plus L, right?
Yes, sir.
Now just consider this. This L will get cancelled, K will get cancelled. So M equals to 0, right?
Yes, sir.
Yeah, so we got M equals to 0. Now if I put limit x tends to A, so f of A will be what I will get here.
K plus L.
Yeah, limit x tends to 1, x square plus, sorry, f of 1, right? So f of 1 will be K plus L only. Okay, so this is about continuous, right? Now, one more condition, it is differentiable also, right?
Yes,
now, this
sir.
function is differentiable, right? Now, what and if this function, if both the function are differentiable, I can say at x equals to 1, it will be equal. So, what is the differentiation of this one?
2kx.
2kx.
Kx, okay, x only. And what will the value of x equal to 1?
2K.
2k.
So, at x equals to 1,
2K.
we have ddx of f of x equals to 2x. At x equals to 1,
That's 2k.
so derivative will be 2k. Now,
Right.
differentiate the next function, that is dd of
2lx
2lx plus k.
So lx square plus kx plus m. It will be
2lx
xl
plus K.
plus m. K
Now add
plus
x equals to 1.
2L plus
The
K.
value
2l plus k.
2l plus k. Right? Now it is
Yes.
differentiable at x equal
These
to 1.
both
So
are
both
also
is be
equal.
equal. So if I
Yes.
equate this,
2l plus k.
2L is equals to K.
2l equals to k. So I have these two conditions, right? This one is first and this one is second. Now I have to find out the value of this. So m equals to 0. Yeah, here you can see x minus 2l is also equals to 0, right? I can simply
Yes, sir.
replace k by 2l, so it will be
Yes,
0.
sir.
Yeah, so the
Is
value
equal
of
to
this
0.
particular equals to 0. Yeah, got it, right? Any doubt in this problem?
Sir, I have just
No,
one
sir.
question. Why we are using this concept of continuity to calculate the differentiability? We can directly do it also. So what is the main motive behind using this notion of continuity?
For this particular question, or you're asking in general?
For general also, I'm asking.
Yeah, like when the function is continuous, only then it is to be differentiable, right?
Yes.
If the function is not continuous, then it is not differentiable.
It will not be differentiable.
Yeah, but when the function is differentiable, it automatically it will be a
It
continuous.
can be continuous or not. That
It
is
will be
also
continuous.
okay.
It will be continuous. Yeah.
Always.
Yeah.
Yes, if it is differentiable, then it must be continuous.
It must be continuous. And if it is continuous, then we cannot guarantee if it is differentiable or not.
It
Yeah.
should be or not.
Yeah. We cannot guarantee if f is continuous, it is differentiable or there is no guarantee. Okay. No guarantee.
There was one question based on this also.
Okay. Okay. Yeah. Okay, so this is about lecture 8.2. Okay, so in most of you have doubt in lecture 8.3 and 8.4, right? Okay, so let us discuss that. But at first, we just quickly revise the standard derivative. What is the derivative of x to the power n?
N to the power n x n
minus 1. Derivative of constant function is 0, right?
Yes.
Yes.
Yeah. So derivative of log x?
1 by x.
1 by x.
Note that it is a natural log, okay?
Sir, if it's a natural log, if it is given log 2 and log something, then we have to change the base.
Change the base, yeah, right.
Oh.
Like if it is given log of x, say to the 5, say 3, okay. So we
Okay.
cannot directly differentiate it. What you can do, log of
Log x
upon log of
by log
Log
the
3.
base
Uh,
3, okay.
Sir,
Now
here
this particular thing is constant, right? My log
Yes.
3 is constant. So I can take outside log 3 to the base 3. Now if I differentiate this ln of x, it will be 1 by x only. 1 by x log of e3, right? So in general,
Okay.
I can say log of x to the any base a, it will be 1 upon x log of a.
Okay.
sir, for changing the base, we
Okay.
can also consider log 10, no, for both sides. If it is a problem or not.
No. We have a differentiable only for natural log. Log of 10x is not, derivative of this function is not equal to 1 by x. It will be 1 by x into
1
log
by
10.
x by log 10.
log
Yes.
10.
There's
Yeah.
a formula.
Yeah.
Okay.
You can remember this formula like derivative of log of x to the base a equals to 1 upon x log of a, or you can simply do this base change rule, right? From limit or from log, you can apply that. So yeah. So what is the derivative of a to the power x?
X times a.
A to the power of x log a to the base c.
Log a, yeah, to the base c, right? Okay.
Sir, how to derive this one? A to the power x, I understand how log e base a.
Just consider this as y equals to a to the power x, right?
Okay.
Yeah, so it will be okay. Take log on both the side, natural log a to the power x.
But why we are taking log?
Because this variable is at the power, right? This a to the power x. If I take the log both the side, I can bring it down.
We
right?
can remove it.
Yeah,
We
log
can
of
remove it.
yeah.
Okay.
So if I differentiate this, I will be get 1 by y.
1 by y.
This is
Is
constant,
equal
right?
to,
That is log a only. But y is a of x, right? Yeah. So yeah. So here it will be dy by dx. So we are differentiating with respect to x, right?
x. Yes.
Yeah. So dy by dx will be y into log of a. But now what is y here? A to the power x.
A to the
right?
power x.
So a to the power x log of a. Yeah.
Okay, sir. Got it. Thanks.
So this is function, right? Okay, I think these are the basic. Any standard limit except trigonometric one?
Sine, cos,
Yeah, so
tan.
that you know, right?
Yeah.
Sir, 1 by x to the power n.
1
Sir,
by x to the power n, right? You can write it as x to the power minus n,
negative.
right?
Yes, sir.
Then apply this formula only.
Yeah.
Like 1 upon x, derivative of 1 by x will be minus 1 by x square, right?
Minus 1 by x.
Yeah. So 1 upon root x will be 1 upon 2 root x.
By root x.
Okay. So just remember the standard derivative and also for trigonometric functions also. Like
Sir, in the inverse function, you just did like tan inverse according like you. Then tan inverse, cos inverse, we can do by this only. If we don't know the formula of the sine inverse and
yeah, you
cos
can do
inverse.
that, but better to revise those formula. Okay.
Okay.
Yeah. Because during exam while solving question, we may not think about that particular substitution thing, right? So if we know the particular derivative of this inverse function, we can simply apply the L'Hospital rule, right?
Can you please write down the sine inverse and cos inverse derivative?
Okay.
Sir, what is the derivative of mod function?
Derivative of mod function exists or not?
I saw it on internet. It is x by mod x.
Sorry, x by mod x.
Yeah. I don't know how, but
the derivative of mod x at particular point will exist or not, because it is not
Continuous.
differentiable. Yeah.
At 0, it is not continuous.
At 0, it is not continuous.
Yeah.
You can apply,
Rest it.
you can try out this limit, okay? No, not this limit.
Okay.
It is not continuous at x equal to 0. So
Yeah, it is not continuous there, but rest it is continuous, they say. So differentiable also, maybe differentiable also. I saw it on internet, that's why I asked.
At which point? At x equal to 0, it is not differentiable, right?
Except 0, everything except 0.
Everything except
Means
0.
in general means either it is less than 0 or greater than equal to 0.
Okay, so it means my f of x will be x when x is greater than or equal to 0.
Greater than 0.
It will be equal to minus s when x is less than equal to 0. Right?
Yes.
Yeah. So, but my limit is will not recover, right? So it is not continuous, right?
And if it is the case, then there is one question which asks for the same thing, means mod of differentiate mod of that value. We have to use that mod function there. That's why I'm
An activity
asking. It is
question.
from activity question. Yeah, there is one activity question. I don't remember it. That's why I'm asking.
Okay, we'll go through the activity question first.
Please check it.
This one.
I have to find. Yeah, yes, this one.
No, this is different question. No? Here, what you have to do, see, f of x is given x into mod of x, right? So it will be x square when x is greater than equal to 0. And it will be minus x square when x is less than 0. Okay. Now try to solve this problem option. Okay.
But why it will be x square? That's I'm not getting it.
When x is less than 0, it will be minus 1, right? Minus x.
Yeah.
I can simply multiply with x only, right? So it is minus x square. When x is positive, it will be x square, right?
Mod of x will be x, no, not x square.
Mod of x
okay.
will be x only, no? So multiply the x. Yeah. Then just try out this function. Yeah.
This function is continuous.
Yeah. Okay, so anyone know what is the derivative of sine inverse x? Anyone?
Sir, what is the meaning of continuous in R and continuous in domain? Its domain.
Continuous in R or domain?
Yes, sir. Somewhere it is continuous. It is domain, and somewhere it is continuous in R.
See, this function is continuous from A to B, right? If I consider this domain as A to B, this function is continuous from A to B, right? And from C to say D, this function is continuous. But between A and C, my function is not continuous, right? Yeah. So for this particular A to B, my function is continuous, and this function is continuous for particular D to C, right?
Sir, how to check the differentiability from the graph, sir?
Yeah, so at this point, we have to calculate differentiability, right? So if that limit exists, by definition, you have to find out the limit at particular point.
Okay.
Yeah. If this exists, then okay, it is differentiable, otherwise no.
But from the graph, sir? By seeing the graph, we can't decide.
By saying the graph, okay, this graph is not continuous at this point, but it is not differentiable.
Okay, it means that it is not differentiable between C and D.
Yeah, because it is not continuous.
Thank you, sir.
It is not continuous in R, and it is not continuous also in domain.
No, domain is there, A to B, right? In whole R, it is not continuous.
Okay.
Yeah. Okay, someone asked about derivative of inverse function. Okay.
1 by root under 1 minus x square.
1 upon the root of
1 minus x square. 1 minus.
1 minus x square. Sorry. Same for cos also, but only minus sign is there, right?
Minus 1 by
minus 1 upon
under root 1 minus x square.
1 minus x square. Derivative of tan inverse of x?
1 upon
1 by under
1
root
plus
1
x
plus.
square.
Yeah,
No, there is no root.
1 plus x square. Derivative of cot x?
Minus 1 by
minus 1 by 1
plus
plus x square. Yeah.
Cot inverse.
No, sorry,
Cot
cot
inverse.
inverse.
Cot inverse x. Sir.
So derivative of what is remaining? Sec inverse x. Anyone?
1 upon
1
modulus
by
x.
1
1
upon
by
1 by
Yes,
x root under x square minus 1.
x square minus 1, right?
Yes.
And for cosec, and you have
Minus
to
1.
multiply
Minus
by
1 by
minus 1.
substituted with -1.
So minus 1
x root under x
x
square.
into x square minus 1. This is 10. Okay. You can search on the internet, or you can refer to any textbook also it is given. Okay.
Thank you, sir.
Yeah. So if we know the standard derivative, then we can.
Sir,
Yes.
question number 5, option 4, please explain.
Activity 8.3, na? I will discuss all the
8.2. At 8.2.
Question number 5.
Option 4, f is not differentiable at 0. Why?
What is the function here?
Yes.
X to the power 1 by 3, na? It is discussed in the lecture also. You can watch the lecture, or you can just find out the limit. Just find out this limit h tends to 0, x plus h to the power 1 by 3 plus okay, whether this function is continuous at x equal to 0.
No, sir.
Yeah, it is not continuous, right? But it is not differentiable also. Simply you can say, right? This I think this example is explained in the lecture. You can watch the lecture also. So let's explain this. Okay, so now once we know the standard derivative, we can go for these rules, right? So linearity means, like, simply if you're given the f of x, say 5x square, say cos of x, then I can simply transfer this derivative to individual term, right? ddx of 5x square plus ddx of cos x, right? Same for minus sign also. And for constant function, like I can take a constant outside and differentiate with a particular function, right? So this is about the linearity. Now this is the important thing, that is the product rule. Product rule, quotient rule, and the chain rule. Okay. So okay, if f of x and g of x are differentiable at a, then so is f g of x and. Okay, so there is a product rule. Okay, so in the 11th and 12th, you must have learned about UV rule, right? The same as UV rule only. Okay, so let us discuss one example. Say my f of x is x square, g of x is sin x. So my f of g x will be x square sin x, right?
Yes.
Now I have to find out the differentiable of this function. Say it is okay.
2x.
Yeah. So what I have to do, if I want to find the differentiation of this function, take differentiable of this any function, this f dash of x, that is 2x into g of a, that is sin x only, right?
So order will not matter here.
Order will not matter, because plus sign is there, right?
Yeah.
Order will not matter. Yeah. Now plus keep the second function as it is, that is first function as it is, x square, and differentiate the second function, that is sin x, it is cos x, right? So it will get this is the answer, right? Now simple rule is that whenever we are applying the product rule, say this is f1 and f2, differentiate the first function, put the second function as it is, plus differentiate the second function, put the first function as it is. Okay. Yeah. Any doubt in this part, product rule? We'll discuss example also.
No, sir.
Now same about the quotient rule, right? I'll take the same example, say sin x upon x square, right? Now, okay. Now if I want to differentiate this function, what I will do? I will first differentiate the numerator,
Sin x.
cos x,
Cos
Sin
x
x first
into
differentiated.
denominator
x
minus
minus 2x sin x
x into sin x.
sin divided by
X
x
square
to the
plus
power
square. X
x
to
to
the power
the
4.
4.
Right? So x square cos x minus 2x sin x upon x to the power 4.
Yes.
Yeah. Any doubt in this quotient rule? But one more thing is that g of x should not be equal to 0 at that particular point. Okay.
Yes, yes.
So we are differentiating with respect to x. If we put x equals to value, it should be not equals to 0. Yeah. So now about the composition, that is chain rule. Okay. So we have given the two functions. So let us consider this one composite function as okay. Take easy example. Okay, can I take just take 1 upon log x. This is natural. Okay. You tell me differentiation of this applying this rule. Can I say my f of x is here x and g of x is f of x is 1 by x and g of x is log of x, right? And then f of g of x will be 1 upon log to the base ex, right? Hello?
Yes, sir,
Yes,
but
sir, but I'm not getting it.
me too, not getting it.
Okay. I want to find out the derivative of 1 upon log x only. Okay.
Yes.
So how will you find out? Is there direct derivative for that? No. Right? So then how to find the derivative of this function? 1 upon log x.
Why we do not do the direct derivative 1 by x?
Yeah, so I can consider this f of x as 1 by x, g of x is log of x. Then my this f of g of x will be 1 upon log x, right? The composite function rule.
Yes.
My fog will be
Everywhere
1
where
upon
there
log
is
x.
x, we will
Now
substitute
just
with log. Okay.
sorry. Yes, yes.
Everywhere there is x.
We will substitute log of x, right? This is my fog composite function. Now just apply this chain rule here, okay, to this particular function. What is given? First, we have to differentiate
1 by x.
So what will be the function? 1 upon log of ex. So what is the derivative of 1 upon x first?
Minus 1 by x square.
Yeah, so minus log to the base ex the whole square. Then derivative of this function, that is 1 by x. So
Okay.
so x into log to the base e x the whole square. So this will be my derivative of this function.
Okay.
Okay. So okay. So let us take one. Not getting it.
Not getting it. Can you please explain? Means how log e to x square, we are substituting that value with x, or what are we doing?
No. Just consider this f of x as 1 by x and g of x is log to the base x. First, we have to differentiate the outer function, that is f dash of x, right? Yes. So my f dash of x is 1 by x, but my x is here log to the log. If I put g of x here, so my x will be g of x, right?
Yes.
So my it will be like this, right?
Yes.
So the derivative of this will be 1 upon g of
minus
x
1
the whole square, right? Yeah.
Yes.
I'm just replacing x by g of x. Now this derivative of this function g of x. G of x is log of e. Log of e derivative is 1 by x, right?
Yes.
Yeah. So that's what I'm doing here. So minus.
Okay. Okay. So we are first calculating the outer and then inner, right?
Yeah. Yes. Yes. So I will take one more example. Simple example.
Yes, sir. One more example will be helpful.
Yeah. Okay. So let us take sine of cos of e to the power x square. Wait. This is sine, then cos. Okay. Then cos is e x square, and then my bracket close. This is my f of x. Okay. Now what we have to do? Take the derivative of outer function. Treat this as any x only.
Sine will be cos.
Cos of e square.
Yes. So cos of e x square. Right. Now, once we take the derivative of outer function, take the derivative of inner function. It is cos x. Right. What is the derivative of this?
minus sin x
minus sin e x square, right?
to the power x square. Yeah. And now we will
the
take the
derivative of this function e x square. What is the derivative of e x square?
power x will be
E x square only, right? Yes.
x square. Right?
Then what is the derivative of x square? 2x.
X square will be 2x.
So this will be the derivative of this particular function.
Okay.
So we have to break down every single individual function that we find there.
Yes, yes, right.
Yes. Now
So
I
then
got it.
first we have to do the
Sin
sine,
x, cos
then
x,
cos,
e
then e
of
to
x,
x
and then
square,
x
then
square.
x square.
There are
Okay.
4 functions inside. This is sin x is one function, cos x is another function, e to the power x another function, and x square is another function, right? So first we differentiate the outer function, that is sin x, that is cos of this particular thing. Then cos of x, that is minus of n of x, right? Then e to the power of x, that's e to the power of x. Then x square ka derivative, that is 2x, right?
That doesn't matter how many function together, we can solve it by this way.
Sorry, how many functions?
There's a 4 function, the 3, 4, 5, many function can be
Yes,
together
sir.
like this.
Yes,
We can
yes, sir.
solve it by this
We can
way.
solve it by chain rule only. Convolution.
Okay.
So if you don't mind, for convenience's sake, like you could take activity 3.8 8.3 is the first question. It has like 4 functions of the same sort.
Okay. So this tangent is in lecture 8.4. Okay, first can we go for this slide and we can discuss all the questions from activity 8.3.
Yes,
Okay,
sure.
yeah. Okay, so this is about the chain rule. Okay. Now, just L hospital rule, right? So if f of x and g of x function, and suppose f of x and g of x are defined on the center at point C, and if this limit tends diverges to infinity or infinity, then when it is computing of this limit, if we cannot use the quotient rule to compute it, since the quotient rule is an indeterminate form. So what do you mean by indeterminate form here? You can simply read out this, but I am interested in this part. What is indeterminate here? What are the indeterminate form?
0 by 0 form.
Yeah, so 0 by 0,
Infinity by infinity.
infinity. The other function also, like infinity minus infinity, right? Infinity
Yes. 0 power
0,
infinity.
0 power infinity also. So
1 by 0 also.
1 by 0 is infinity only, no?
1 by 0 is infinity.
1 to the power infinity. Right? So if you come across this type of particular function, try to convert this into this form, 0 by 0 or infinity by infinity form. Okay, and then apply this L hospital rule. Okay, because we can apply this L hospital to this particular form only, 0 by 0 or infinity by infinity. But if you come across this particular indeterminate form, try to convert it into this particular form. Say for example, say x sin x, right? So if limit x tends to infinity, so what will the value? Is also infinity into infinity, right? Not infinity. Sin infinity is not defined, it is infinity, right? So I can write it as sin x upon 1 by x, right?
Yes.
Yeah, not infinity, say 0 also. Okay. Okay, maybe a different example we can do. But you understand, right? We can apply this L hospital rule if we have 0 by 0 or infinity by infinity form. If you have other form, you can convert this into this form by simplification and then try to apply L hospital rule. Okay, so now let's take
sin x by root x. Okay.
Sin x by root x, that is 0 by 0 form only, right? Yeah. Okay, so okay, let us solve this function. So if I put 0 here, what I will get? Log of 1 upon x
Log of
by
1 by
0. So that is 0 by 0 form. And if I simply differentiate the numerator and denominator. So in L hospital rule, what we do? We differentiate the numerator differently
and
denominator differently. We are not applying the quotient rule here. Okay. Quotient rule is something different. We are just simply differentiating the numerator and denominator individually. Okay. So if I differentiate this function, again, this is a composite function, right? What is the differentiation of this log of 1 plus x?
1 by 1 plus x. And
1 upon log of 1 plus x plus derivative of 1 plus x, right? That is 1
plus
only.
x. 1 only.
Yeah. So the derivative of x is 1.
1.
So now
So
if
this
I apply limit x tends to 0, what will be? 0 only?
Yeah, 0 only, 1 by 0 only.
Yeah. So it will be infinity.
So
It will be again
this is 1 plus x only. Log e 1 plus x,
Oh,
derivative
sorry.
1 plus x.
Yeah. So it will be 1 plus x only, right?
Yes, sir. That's why x equal to
Yeah.
0. So this is 1. 1 by 1 is equal to 1.
1 only, yeah. So
Yes.
this limit equals to 1. We can discuss few examples directly. It will be better. Okay, so at point 3, question 1. This function, right? This composite function. So we have to find out the derivative of this and derivative of this, right? There are two functions, right? Only. Okay, so let us find out the derivative of x square cos x. So tell me how to find.
Then the outer function is e to the power x square cos x will be there.
Yeah. So differentiation of this e to the power x will be e to the power x.
A to the power x. So
X square
As it is
cos of
cos
x.
x as a,
Now
and
as
then
differentiation of x square into cos of x.
cos x. Yes.
So I can continue this at e
2x
square
So
cos of
this
x.
is the UV form. So
This
we
is
can
the
say
form,
2x cos x plus
2x
x
cos
square
x
minus x square minus x square sin x minus
sin x, because derivative of
x
cos x
square
is
sin
minus.
x
Yeah,
x
into
square.
x square, right?
Yeah.
So which one is correct? Yes, you can take this 2x cos x. Yeah, this one is correct, right?
Yes.
Option 2.
Fourth one.
Yeah. So now let us take the derivative of second function, that is e to the power x sin x.
Yes.
Same thing is there, right?
Same thing. E to the
First,
power x sin x.
then derivative
Then
of
in
this
the
particular
bracket
function.
sin x plus
Yeah. So it will be e to the power x sin x.
and
Then
the bracket sin x plus x cos x.
plus sin x, right? So yes, this is my correct option.
Yes.
Does someone have any doubt in this question?
But I'm having doubt in question number 8.
The question number 10, can you please explain?
Sir,
Okay.
question number 2, sir. 2 sin x by root x.
Okay, we'll quickly go through all the questions.
Okay, sir.
Okay, so what we have to find out? Okay, you can simply put 0 here, right? So it will be 0 by 0 form.
Yes, sir.
So differentiate it cos x. What is differentiation of root x?
1 by 2 root x.
Differentiation of root is 1 by 2 root x, right?
Yes, sir.
Yeah, so I can write this as 2 root x into cos x, right? So x equals to
Yes.
0, this will be 1. And under root of 0 is 0, so answer is 0.
0 is equal to 0.
Okay, so okay, in third function, okay, same thing is there, like x square when x is greater than 0 minus x square when x is less than 0, right? Now f is differentiable on you can check it. Derivative of this is 2x minus 2x. Okay, you can try out this. Now question number 4.
4, sir.
I have to solve this question. Okay, anyone approach this question? Anyone?
Yes, sir, I have done it.
Yes, sir.
yes sir, done.
Yeah, so just simply put f of x here. So what is limit x tends to 1 under root of 9 minus x square minus f of 1 is under root of 8, right? If I put x equals to 1, 9 minus 1 under root of 8. So that is x minus 1. So we have to find out the limit here. If I put x equals to 1, I will get under root of 8 minus under root of 8, that is 0. It is 0 by 0 form, right?
Yes.
So I can simply differentiate the numerator and denominator. So what is the differentiation of this numerator?
1 by 2 root 9 minus x.
Dx of under root of 9 minus x square. Because
Minus
differentiation of
2x
minus 8 is 0, right?
into minus
Sir.
2.
So 1 upon 2.
2 root 9 minus x square, but x square is also there, so 2x.
Yeah, so
Minus
differentiation
2x.
of 9 minus x square,
Minus
that is
2x.
minus 2.
Point
2 cancels.
minus
2x.
2 will cancel. Yeah, so I can write it as x upon under root of 9 minus x square. This is a differentiation of numerator, right?
Yes,
Now,
sir.
denominator will be 1 only.
1.
Yeah. Now, apply the
So
limit.
it will be minus x, right? Minus x by root 9 minus x square.
Minus
Because we have minus 2x by 2.
Yes, minus.
Yes.
So if I apply x to
minus 1.
be
1.
minus 1 under root of 8. Answer is minus 1 here.
So root 8 is outside the limit extending to.
We have to multiply by root 8, right?
Root 8, that will be cancelled.
So this one will get minus 1. Okay.
Sir, I am confused. Here we have not used the u by v formula.
Uy determinants.
U by v function of x minus function of
Quotient rule.
Quotient rule.
Yes,
No, we are not
direct
finding out the
derivation is not
derivative.
given.
Yeah, we are finding out the limit here, not derivative, right?
Okay.
We are differentiating numerator and denominator individually. Okay, fifth question, anyone? This is which form? If I put x equal to infinity into e to the power infinity. It will be infinity into 0, right? Yeah, but I can write it as x upon e to the power infinity, sorry, x, right?
Yes.
Yeah.
Yes.
Limit x tends to infinity, that is infinity by infinity. Just differentiate numerator and denominator.
1 by 2 divided.
Yeah, so 1 upon e to the power infinity will be 0, right? Any doubt in this part?
No, sir.
Is this 0 approx or actual?
No, 0. It will tend to 0. It will tend to 0.
Yeah, that's
Okay, now this function, what is the question? Number of correct statements. So we have given the fourth statement, how to find out? So we have two functions, this one and this one. Simply we have taken the derivative of this, right? Any doubt in this question? How to
Sir, previous question, sir, 1 second. Limit extends to infinity x into e power minus x. That is actually in the form of u into v, no, sir. You should do u dv plus v du, right?
Which one?
Fifth question. Fifth one, yeah. U d by dx of v into v d by dx of u should be done, right?
No, we are not calculating the derivative. We are finding out the limit, right?
Yeah, but applying L'Hospital rule is nothing but finding derivative only, no?
But you have to find derivative of numerator and denominator
Derivative
alone.
is a process in L'Hospital rule.
Yeah,
It is
L'Hospital
not
rule.
to find it. It's not.
It requires to find derivatives numerator alone and denominator alone. You cannot find derivative of both.
That is a process of that rule.
So while finding out the limit function, if you come across indeterminate form, that is 0 by 0 or infinity by infinity, then only you have to apply L'Hospital rule. That is, you have to differentiate the numerator separately and denominator separately. Okay?
Yes, sir. Yes, sir.
Yeah.
Sir,
Yes.
activity, yeah, same activity, question number 8, sir.
Question number 8 we are going. Yeah, just 1 minute. Okay. Any doubt in question number 6? I have to differentiate these two functions.
No, sir, I don't have any.
7, sir.
Okay. You can try, right? Yeah. Simple composite function.
Question number 7.
Question number 7 or 8. 7.
We have to find the indeterminate form for
simply check
which are
whether 0 by 0 or infinity by infinity. Right? So this it is infinity plus. Can we evaluate this limit using derivative?
The first option is also infinity by infinity.
But it is not given as.
Just take x common. You can directly solve it, right?
1 plus sign.
And limit extend to infinity will be 0. So the answer will be 1.
You can find it.
Same you can apply for option 2, 3, 4 also, right?
Okay, sir.
Question number
8.
Okay.
8.
Okay. What we have to find out? f dash of 9.
F dash of 9.
Given this 9, 0, f. Okay. So I can write it as f of 9 plus 0. So my f of x will be 9 and f of y will be 0. Right? I can consider this as 9 and y as 0. Hello?
We can do it.
Right?
Yes.
We can do it.
Yes, yes. So simply we need to differentiate f dash of 9. Right? So it will be
24.
Yeah, so 9 and derivative will be 424, right? 24, 6 into 4, sorry.
Sir, can you explain this again, this entire 8 one, like how to start, just starting point?
Okay. So we have given if x plus y equals to f of x into f of y for
Yes.
all values, right?
Yes.
So we have given f of 9 is 6 and
9.
f dash of 0 is 4.
Okay.
So I can, by looking at this thing, I can consider x equals to 9 and y equals to 0.
Okay.
Right. So my f of x will become 9 and my f of
9.
y will become f of 0. Okay.
Okay.
That is not given. So this function will be 9 plus 0, right?
9 plus 0.
Yeah. So if I differentiate it, it will be f dash of 9. So here, what I will get? We have to find out f dash of 9.
So we will use that UE formula here. Or not?
24. Wait. You don't need to use the formula, right?
Can you please do that math stepwise?
I'm also thinking.
So we are given only two values, f of 9
Yeah.
and f dash of 0. So like,
I think f of 0 should be given there.
yeah, something more should be given.
Sir, it will
F
be
of
solved
y
by
is equal to 1. F of y is equal to 1 from this statement.
Yeah. Wait. I'm writing it down. So. F of y means f of 0.
F of 9 plus 0 is equal to f of x and f of 9 into f of y.
So f of
y is
9
equal to 1.
equals to f of x.
F of 9 plus.
Sir, f dash of 0 is given, so that means f of 0 can also be 4 according to a rule that says if the
Sir,
function
f of not.
Yes.
then it's differentiable also.
Yes, I got it.
The
See, we have given this, right? So I can consider x equals to 9 and y equals to 0. Okay. So what of f of 9 plus 0? It will be f of 9 into f of
Into
0.
f of 0.
So f of 9 is what? 6. 9 plus 0 is f of 9 only.
No.
6. Here will be 6
Okay.
also. F of 0. So f of 0 will be 1 from this, right?
Okay.
Yeah. So f of 0 will be 1. Now we have to find out the differentiation of this, right? This one. So f dash of 9 we have to find out. But what is f dash of 9 here? 6 into f of 0. Now if I differentiate it, f dash of 9, 6 constant, right? Differentiation of f dash of 0, right? So f dash of 9 is given, not given, right? Okay, we have to find out f dash of 9.
F dash of 0 is given.
F dash of 4 that is 6 into 4. That is 24 only.
Okay.
No need to apply product rule also. Simply we can do, right? Yeah, no need to find f of 0.
Okay, simply we can substitute this 6 into f of 0 for f of 9.
From this we'll get
And
this
then 6
function,
as
right?
constant will come out.
Yeah. Okay, so f dash of 0. Okay, even if you apply the chain product rule, you will still get the value, right? Yes, because we have got this value f of 0. You can try out, okay? You will get the same value, 24. Then numerical denominator. Okay, question number 10. Anyone? Any doubt?
Yes, sir.
Yes, sir.
What is cot 0? What is sin 0?
Infinity cot 0, sir.
Cos 0 infinity, infinity into 0. Okay, so I can write it as sine 4x upon tan x.
Yes, sir.
So limit x tends to 0 because cot x equals to 1 upon tan x, right?
Yes, sir. Yes, sir. Yes, sir.
So from this I can write it like this. Now if I put sine 0, 0, it will be 0 by 0 form.
Yes, sir.
Apply L'Hospital rule. That is cos of 4x into derivative of 4x, that is 4 upon derivative of tan x is x square x, right?
Sec square x.
So now apply limit x tends to 0. So cos 4 into 0 will be cos 0, that is 1. So that is 1 into 4. Sec square 0 x will be 0 will be like 1 upon cos square x, right? So cos 0 is 1, so it will be 1. So answer will be 4 only.
It is 1.
Yeah.
Okay.
Right. So
Okay,
you can solve this by without applying the L'Hospital rule also by using the standard limit. Anyone how to solve this by using standard limit?
By log, sir.
4x,
Both sides.
sin x,
Yeah.
sin x 4x by 4, and x by tan x by x. Then it will be 4.
Yeah. So
it will be 1, then we can
4x,
take out 4 common.
tan x by x.
by x. Yeah, is
So
equal to 4.
limit is this is 1 and this limit is also 1 when x tends to 0, right? So answer
Yes.
will be 4 only, right? Without applying the formula also we can do that.
Okay, sir.
Okay, any doubt in that point? Yes.
I'm confused why in this we have not used the percent formula UIV formula when it is used to derivative formula and when it is used for limit only.
No, we are only finding out the limit. Okay, so this L'Hospital rule comes only for the limit, not for derivative. Derivative of this function is different. This is something different, and this is different. Here we have to apply the product rule, but here we are just finding out the limit of this particular function. And while finding out the limit, we are coming across indeterminate form, and then we can apply the L'Hospital rule, right? It is we have to differentiate the numerator and denominator separately. We are finding out the limit here, not we are taking the derivative. Okay.
So question number 9. Option first, sir.
Okay, 1 minute. Yes.
Sir, in lecture 8.2, we for limit also we can we take the numerator limit and denominator limit separate. Then here why we take the derivative?
No, you can without taking derivative also you can solve this question, right? Just apply the standard rule, like just divide it by x, both the numerator and denominator, and for making this term 4x, we have to multiply by 4x, right? So this limit is equals to 1 and this is also equals to 1. So that is 4. So this practice.
Okay.
So by looking at this function only, I can see, okay, I can, if sine a x, so I can simply say that, okay, if I can bring this term in like this, I have the standard limit function, that is limit x tends to 0, sine of x equals to 1, right? And I can apply this limit. I will try to make that function in this form. Okay.
Okay.
Yeah. Yes, question number 9.
Option first, sir.
Option first. Okay. Distinct function R2 are statement. F of G is differentiable, then both F and G are differentiable. This is not correct. Okay. So
Inverse of it's correct, sir, right? If F and G are differentiable, then we can say F and G are differentiable. But
yeah.
this statement is not correct.
Yeah, its reverse is not true, right? Yeah. You can note down this, right?
Yes, sir.
Yeah. So even differentiable function, then F is odd function. Okay. Any even function you know? Any odd function you remember?
No, sir.
Even sin x.
Sin x.
No, sin x is odd function, right? Cos x is. So derivative of cos x will be sin x, right? Minus sin x.
Minus sin x.
That will be odd function, sin x. And derivative of odd function, that is sin x equals to cos x, right? Derivative of this, that is even function. Or you can consider like this, x to the power 4 is even function, right? If I
Yes.
replace
We can take
x by
square and
minus
cube, sir.
x, yeah, the square and cube is also fine, right? So even function is x square, odd function is x cube. If you differentiate, you will get 2x, that is odd function. If you differentiate this, you will get 3x square, that is even function, right?
Okay, sir.
Yeah.
Sir,
So like,
option 2.
sorry,
Option 2 in the same question.
option 2. Okay, assume that g of x is not equal to 0. And if f of differentiable, then both f and g are differentiable. No, its reverse is not true, right? If f and g are differentiable, then only f upon g is differentiable.
Yes.
Same as option 1. It is the reverse of that, right? It is not true. You can go to the slide. It is given in the slide, I think. This rule, right? Just the reverse of the statement is given here. Okay, so one more thing is like last part is this tangent and derivative. Okay, so let f be any function differentiable at any point a, then the tangent of f exists at that particular point and is given by this expression. So y equals to f dash of a. So we differentiate that particular function, put the value x equals to a, then x minus a, and then f of a. Okay, so it will give the equation of tangent. Now, for what is linear approximation? Same thing is there. Like if f of x is differentiable at a, then the best linear approximation is given by this particular function. Okay, so conversely, you can say if there is a best linear approximation for f at a, then f is differentiable at a. So approximation is given by this. Okay, so it is same thing. So only I think these two parts there in the
Sir, can
last.
you elaborate a little bit linear approximation? I have gone through lecture, but I didn't understand exactly what it is meant for. How can we apply this in questions? That linear
A
approximation
linear
part.
approximation, say suppose you have to find out value of any function.
Right, sir.
Yeah. So like there can be any complex function, right? So you can use this linear approximation. You will get the approximate value of that particular function by using this. So it's any example in any activity question.
7, sir.
7 you can see. We are given this function, right? And we have to find out the value of under root of 4.4. So what is the best fit, best approximation for this? It is what is the L of x will be f dash of a x minus a plus x of a, right? F of a, right? So just differentiate this function. What is a here? 4, right? So just differentiate this function. What is differentiation of root x? ddx of root x?
1 by 2 root x.
1
1
upon
by 2 root
2
x.
1 upon 2.
Now if I put x equals to 4 here, add x equals to 4, because we have to put a, right? So it will be 1 by 4.
1 by 4.
So it will be 1 by 4 x minus 4 plus what is f of a here? Just put x equals to 4 here. 2, right?
Yes, sir.
So this is my linear approximation for this particular function. Now we have to find out the approximate value of 4. Just put x equals to 4.4 here. So 1 by 4, 4.4 minus 4 plus 2, it will be 1 by 4, 0.4 plus 2. So it will be 0.1 plus 2, it will be 2.1, right?
Okay. So
Same.
I solved this question by directly putting 4.4.
No. In calculator, you will get the same value, but we have to
Yes,
apply
sir.
this linear approximation, right?
That's why I asked you, sir.
So what if you have some dirty, very complex function? In that case, what you will do? Right?
Yes, sir.
You have
Got
to
it,
find
sir.
out the linear approximation. Right? Same thing is for question number 8. This function has been changed. Put the a equals to 0 and find out the x equals to 1.01 to the power 4. Right? So here we have to find out the value of. Okay. So what I have to put x equals to 0.1, right? No. X equals to what I have to put. Anyone solve this question? Question 10, question 8.
Yes, sir. X is equal to
Yes, sir.
0.01.
x equals to 0.01. No. We have to find out x equals to 1. Yeah, right.
It has been solved on the forum.
Okay.
Solution has been given.
Okay. We can check it. So
It's
yeah.
answer wrong, na?
Which answer is wrong?
Question number 8 answer.
No. Is it wrong?
Sir, in portal the answer is 1.0.4.
In the portal, answer is being x is equal to 0.01. Here is the 1.01.
Okay. In portal question may be different, right? Approximate value.
Sir, portal question is same, but the answer
Question is same, sir. Answer is 1.0.4.
Okay, let us solve this. Function is same and the approximate value
Yes,
is
sir.
also
Same.
Yes, sir.
same,
Yes, sir. Same, sir.
Answer is 1.04.
Let us try. What is the derivative of this? 3, right?
Yes, sir.
Yes.
If I put x equals to 0, 4 only. 4. X minus 0 plus.
Lx equal to 4x plus 1.
Sorry.
4x plus 1.
4x plus 1.
Yes.
It is 4x plus 1 only. Now put what we have to find out? 1.01.
Yes, sir.
To power 4. So if I
Sir, in one of the on-demand session, Shrikant sir said that we have to take x is equal to 0.01.
Yes,
sir.
x equal to 0.01 we have to take, so
Yes,
that
yes.
answer will be 1.01.
Yes, because if you take the fourth power also, it will not reach to 5, right? Anyway, it will not reach to 5.
Yes.
Yeah, this is not correct. You have to put 0.1 only. So if you put 0.1, so what will be 0.4 with plus 1, it will be 1.04 only, right? Yeah. Okay, so these two is solved. Any doubt in last activity?
Sir, question number 7. Actually, I got disconnected.
Question number 7. Same approach you have to do. Like, what is the linear approximation formula? That f dash of a
Dash of x minus a plus f of a.
Yeah. So f dash of a will be 1 upon 2
1 by 2 root x.
At x equals to 4, at a equals to 4, it will be 1 by
1
4.
by 4.
So 1 by 4 into x minus a plus 1 upon f of a will be 2, right? So the equation will be 1 by 4 x minus a plus 2. Just put, so not x minus a, x minus 4. Just put x equals to 0.14 here. Yeah, you will get the answer.
X is equal to root 0.4.
Sorry?
X is equal to root 4.4. We have to put.
Yeah, x equal to 4.4. You will get this value 2.1.
Okay, sir.
Yeah.
Hello, sir.
Yes.
So I got the how to solve and how to approach the question, but I am still in dilemma. Why are we solving this? What is the concept behind this linear approximation? Why are we finding this?
Like, say, suppose there is many complex function, we have to find out the value of at any point. Okay. Of
Okay.
that. So we can simply use this linear
We can
approximation.
get an approximate value.
Value, yeah.
Okay, sir. Got it.
That's it.
You
So
can
instead
even
of,
think it.
sorry.
We can even think it as means finding the best line fit that SSC we have learned in week 3 or week 4, whatever.
Baseline fit will be different.
SSC is
it
different a bit. It is a different thing.
Yeah, it is different. Baseline fit is different.
We can find the function using this, right? We can find the actual function using this, even the tools of calculus.
Yeah, we can find out. So what happened? My screen is visible?
Yes, sir. Yes, sir.
Okay, okay. Okay, question 1 is fine, everyone. So you have to calculate M1, M2, M3 and just add it. Any doubt in activity 4.1?
Question number 2, option 2, sir.
Question number 2, option 2.
Yes, sir.
Tangent to the parabola at a vertex is y equals to k. So same thing. What is the equation for the? We are given the function is differentiable at point A. The tangent for f will be this, right? Yes. Just apply this thing. You will get, what is the vertex here for this parabola?
Okay.
What will the vertex? Anyone?
H comma K, sir.
H comma
K, H comma K.
X coordinate will be H, right?
Yes, sir.
Yeah. So just apply this. You will get y equals to k only.
So we can even use the intercept way of means transferring the k to that side, making
Yes, sir. I have also solved it by that manner. The slope point form.
Yeah, but here in the context of this week, we have to solve by using this equation, right? Tangents.
Okay.
Yeah, right. So like y equals to a x minus x plus square plus k. So this is my f of x. So just apply this. What will be my vertex is k, right? Sorry, h.
Yes, sir. H.
Yeah. So our here a will be, so this a and this a are different. Okay.
Yes,
I
sir.
will consider this as m. So my tangent equation will be, say, p of x will be f dash of m p of x will be f dash of m x minus m plus f of m, right?
Yes.
Where m is h. So just differentiate this function. What will differentiation of this? A
2 of a.
x minus h, right?
Yes, sir.
And when x equals to h,
Become 0.
no, wait.
At x equal to h
Yeah.
equal to 0.
At s equal to 0, right?
Yes, sir. Yes.
F dash of a will be 0. So 0 into x minus m plus f of m. So my f of m will be
K.
k only, right? If I put h, it will be 0, k only. Yeah. So I equal to k.
Okay.
So in this whole week, just remember these two equations only for tangent and for linear approximation. This you have to find out the derivative at particular point, put the value of a, then just put the value of a in the function and form the equation. You will get the answer. Okay. In all the
Excuse
cases.
me, sir.
Yes.
Sir, how long this session going on, sir? Because there is another session.
Yes, we are just last question, right? Any doubt in this part? We have done the lecture 8.4 also. Yeah. Any doubt in any activity question?
Activity 8.2, question number 8.
This is fine. 8.2, question number 8. This sine function, right? Mod of sine.
Yes, sir.
Okay. So what is the graph of mod x? Sorry, what is the graph of x first? Y equal to x, like this, right? Hello.
Yes, sir.
Yes.
What is the graph of mod x?
V shape, sir.
V, sir.
Yes.
V shape.
V shape means what? It will be like this, right? So my negative term will become the whole positive side, right?
Yes, sir.
Yeah.
Yes,
So
sir.
what is the graph of sine x? Just one minute.
Sinusoidal curve.
I will share it again. Yeah. So what is the graph of sine x? Like this. Sinusoidal curve.
Sinusoidal curve.
Right?
Yes.
Yes. Now, what is the graph of mod x?
Sir, we have to eliminate that negative part. It would be like, yeah. Just shift that negative part to upwards.
It will be
Positive x-axis.
Yeah. So my graph will be like this, right? So this.
Yes, sir.
This.
Yes, exactly.
Yeah. So it is periodic with pi, right? This is a pi. It will repeat after pi interval, same graph, right?
Right, sir.
So the option one is everywhere continuous and differentiable it is continuous but not differentiable at this point.
It is not differentiable.
Yeah.
At 5
Everywhere
points.
continuous but not differentiable at n point. This one is correct. Neither continuous, this is not correct. It is continuous, right?
Yes.
Right, sir.
Yes, sir.
So these two options.
Question 7 also explain, sir.
Question 7. Okay, there exists a function r such that it is not differentiable exactly on a set of natural numbers. Any function is there which belongs to R to R and f is not differentiable exactly on a set of natural number. Set of natural number means what?
1, 2, 3, 4, sir.
1 to infinity, any value, right? And
Yes.
To
Right, sir.
infinity.
yeah. So exist function is not differentiable at this point. Exactly on the set. So any function is there.
It is possible.
Sorry, possible any function, but I don't remember the function. So it is possible, right?
Yes, sir, it is possible.
Yeah. Inverse of
Shilpa,
differential
can you
function.
mute yourself?
Yes, noise is coming. Okay. So option 2, inverse of differential function is differentiable, not true. Option 3, f of x square for x rational and equal to 0 for x rational, then differentiable at x equals to 0, right? So limit extend, yeah, 0, right? So it is differentiable.
Sir, question. Sir, 8.4 question number 5.
Okay. This one.
8.4 question number 5.
8.4 question number 5. This one, Dina.
Yeah, it is passing through some point 5, 8, and what will the value of f differentiation at 8.1?
We have to find out the tangent line to the curve. So what is the equation of tangent? Like we have just seen, right here. Y equals to f dash of a x minus a plus f of a. So in the function tangent on the curve, f. Okay. So curve represented by a function f at a point this passes through the point 5, 8, right? So when x equals to 5, y equals to 8.
We can just calculate the slope that I get, but I don't know why. 1 second, I don't. Okay. This one, yes. I am getting 0, sir. Why?
Wait. You are getting 0.
Yeah. I am just calculating the slope using this. 5,
Okay.
8 and 0.
Okay, so wait. Okay, you are using these 2 points only, right?
Yeah.
The tangent line to the curve represented by a function at a point passes through the point. No.
Answer is 2, sir.
Answer will be
Simple, we have to apply y2 minus y1 upon x2 minus x1.
Yes, answer is 2.
Yes, sir. Answer. I have also done it that way. Y2 minus y1 upon x2 minus x1.
So what
because
is
we
the
have 2 points and we just have to find the slope.
Okay.
And
That I get. Then how
In the context of this week, like by using this, how we can get this value, right?
The slope of this line is always
f of a slope.
Yeah, I know that. Like 8 upon 5 minus 1, you will get 2, right?
Yes,
But
sir.
by
That
using this
So
equation, how will
is it wrong, sir? Just asking. Is it wrong?
In exam, you will have to enter the answer only, right?
Yeah. So approach
it
doesn't
is not
matter.
No. You are calculating the slope of that particular line.
2 times x minus 0, x minus 1 plus f of 1, it says, right? But where
Okay,
is the
so
function?
if instead of where is the function? Now here, if we use this equation, how to solve that, right?
Yeah.
So here a equals to 1. We have to find out this, right?
Yes.
This thing we have to find out. So my tangent will pass through this point, right? So when x equals to 5, y equals to
8.
So I can write it as y equals to 8, f dash of 1, x is 5 minus 1 plus f of 1, right? So we have to find out this. So 8 equals to f dash of 1 into 4 plus f of 1. Now when x equals to 1, y equals to 0.
It is 0.
Right? So f dash of 1 will be 2, right?
Right. So everything is
Okay.
in front of our
Got
eyes
it.
and we can't interpret. Sir.
I'm not able to get it. What is A? What is A over here?
Yeah. By looking at this function only, I can understand that A is 1, right?
So we can also find the
equation of the line, right?
Yeah, we can also find the equation of the line.
Yeah, I just found the equation of the line and then substituted, calculated the derivative at 0.1.
Yeah, that also you can do. But in the context of this week I'm talking about, we have to solve this question by using this equation, right?
Okay.
Yeah. Okay, any doubt in any of the activity question? Do you have another class? Like many students left the class.
Yes, sir. CT class is going on 8 to 10.
Okay, fine. Okay, I think we can close the session then.
Thank you, sir.
Thank you, sir.
Sir,
Yes,
can we, sir, hello?
Excuse me,
Sir, can we expect a on-demand session before deadline? Because some of practice assignment questions are boggling a little bit.
Next session is tomorrow's session is there. Solve with us. So you can ask your doubt.
Okay. Tomorrow is to solve it. I can't see it in my calendar. Let me refresh. Sir.
Yes, sir. Yeah.
It is
Tomorrow at
8
which
to 10
time?
p.m.
8 to 10 is there.
8 to 10. Okay.
Tomorrow. Yes, Shilpa, you want to ask me that?
Yes, sir. I had multiple things to talk. I don't know if you have time. We should set a different session, maybe.
Okay, you can ask your doubt.
Yeah. So I have first of all doubts on the graded assignment. Some questions. I feel the scenarios they have not been covered. I might be wrong. And the graded assignment for week 8, yes.
Okay, let me check. Concepts are not covered.
Sorry?
You mean concepts are not covered for those few questions?
Yes. And second thing was that, I mean, it's a feedback that I feel we are repeating some of the questions like who are exact same in nature. Reason being, maybe some of the candidates did not get time to go through the previous videos and sessions. So, I mean, I think that is at the cost of covering up some more advanced concepts and practicing some more advanced questions, or like this is how this is that both the sessions would overlap by a greater extent.
Like you want to say like we can take different example other than activity and practice, right?
Okay.
Like you want like this other examples, advanced example. Yeah, that we can do, but first we need to cover the activity and practice question out, right?
Okay. All right. So question number 8.
Question number 8. Okay.
Question number 8 and question number 10. Little bit of hint there would really help.
Now here you can see the f of x is continuous, right? So we have to apply those left hand limit equals to right hand limit, right? From that you will get the value of a.
Yes.
So you can simply put this. Just equate this. Just apply this concept, right? I will not discuss this question as a graded part, but when the function is continuous, left hand right limit should be equals to right hand limit, and then f of 0, like here x equals to 0, f of 0 should be equals to limit x tends to 0 to this function, right?
Okay.
Yeah. So in the question then, okay. So this question and
the last part, the last bound. So for function PT, the third condition. Some hint on evaluating it for function PT, not QT. PT.
PT, okay. Third condition.
Yeah.
Yeah. So when a function varies from 0 to 6, it will lies for this function, and after t equals to 6, it will be 2. Like what you can do is simply you can like what I have said earlier. The function is said to be continuous, right? So when limit left hand limit should be equal to right hand limits, right? And it should be equal to the value of that a, f of a. So f of a is given as 2 here. Now just equate it. What we have to find out in this question, but
yeah, it's not only talking about continuity, it's also talking about differentiability.
Yeah. So first you need to check whether this function is continuous or not.
Right.
Continuous, then you can go for the differentiable, right? Limit x tends to infinity, that particular thing, right? If it is not continuous, then no need to check about the differentiable.
Okay.
Yeah, so same thing is there. You have to do for both the functions. P of 10, P of 10. You can try out, okay? I will not discuss now, it will be a question.
Sure.
So just whenever there is given that f is continuous, so always consider left hand limit equals to right hand limit, and the value of that particular limit should be equals to the f of a. So if you satisfy these three conditions, you will get some equation. Try to simplify those equation, you will get the answer.
Sure. Thank you.
Okay. Thank you, everyone.
Thank you, sir.
sir.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.